Okay, hello, good evening. Thank you all of you to be here. I would like to also thank you the DevOps Lisbon organizers to invite me to be here today. And I'm here to talk about highly productive delivery culture for continuous delivery at Mercedes-Benz IO, which we did it, of course, doing or adopting a DevOps culture in our company. I would like first to start with just a few words about me. My name is André Macedo. I'm 35 years old. I started my journey when 48 Ks of memory was enough, so it was maybe in the 90s, I don't even remember. My first programming language was TCL script in 96, so I'm in this IT since ever. I've been working in telco, media, and most recently at automotive area. And currently, I'm working at the architecture and technology at Mercedes-Benz.io. Now, also a few words about our company. So you see those plants there. This is our office. So this is not a picture from Google. This is me, as you can see, in my desk. We are a different company, not like a standard IT company. We want to be different. We were born in 2017. We are a company from the Daimler Group. Our main purpose is to drive the digital future of Mercedes-Benz. So we know we have the best cars, but we also want to provide the best digital experience to our customers and also prospects. Currently, we have offices in 3 locations, in Berlin, in Stuttgart, and Lisbon. We are being driven currently by 240 employees, plus external partners, and we are still growing. And our solutions currently are being delivered to more than 100 countries. If you want, you can visit our website. We have open positions if we are growing. If you like this talk or if you want to work with us, just go there and apply. We are a company with 1 year and a half, but of course our software solutions were not built from scratch. So when we started, there was an initiative in Daimler to insource some of the strategic projects of Mercedes-Benz, but of course the solutions were being developed by our partners for a couple of years, so this does not mean that we build everything from scratch. And of course, when we start realizing, okay, we need to do some changes in the projects, because the way they were working was not the way we would like to work. So the first important thing when we start our journey was the transition manager role. What does the transition manager hold us? This is someone which is responsible to insource one project or one product or one team to Mercedes-Benz IO, and basically he's responsible to build up a plan with 4 main steps when he does the analysis, of course, of the project itself. Then we do some pairing when we start sharing the knowledge with our external partners and start to getting more in terms of the product itself. Then we define our target architecture, because sometimes to do DevOps, we need to change our architecture. That's needed for sure, so that's why we do it. And then the last step is migration to our platform. And normally after that, we are able to work with this DevOps culture and have a team managing basically everything. So, and to do so, what we had to do, so we take a look at our development flow in the past. So this is just before Mercedes-Benz IO, and we had a typical development life cycle: the inception, where the idea comes up, then the requirements and architecture, the infrastructure provisioning, the implementation itself, and then the deployment and integration. And we realized that from the beginning until the end, normally we would not deliver anything in less than 30 days. And of course, this is not enough. We want to react fast, so we decide to, and this is where we are at the moment, to parallelize some of the steps, and some others we just kick out and they are not part of our development flow at the moment. So we still have the inception. This is needed. We cannot get rid of that. We have the requirements, architecture, and design and implementation at the same time. So this means we bring all the capabilities to one single team. I will talk a little bit about this in the next slides. And then we have the deployment and integration. And one very important aspect, the infrastructure provisioning, is no longer part of our development lifecycle, or it is, but in a different way, and we will also see this in one of the upcoming slides. And currently, we are able to have an idea and put it live to our customers in 2-3 days, sometimes less, sometimes more. It depends, of course, on the complexity of what we are doing, in the maturity of the team itself in terms of this DevOps culture that we have. But in general, we are pretty happy with our current development flow. One very important aspect, we also, this is in the DNA of our company since the beginning. We don't have classical hierarchy as other companies. We adopt holacracy, which is a flat hierarchy framework. Instead of having departments, we are organized in circles, and then inside these circles, our people has roles and accountabilities assigned. So this means if I'm a software engineer, that does not mean that I cannot contribute to other area of the company where I have knowledge for that. Also, one very important aspect, no top-down decisions. Normally, we give our people some freedom, and with that, and these four words are here, I think, are crucial for our DevOps culture, which is responsibility, freedom, autonomy, and fast decisions. If we want to do DevOps without this, we don't think it's possible. So this is one of the reasons why we adopt holacracy as a framework to manage our company. Again, goes to the teams. Currently, we have more than 50 teams, so we are not so small as we were in the beginning. Our teams are responsible for the whole journey. So this means if someone has an idea in the team together is able to put this live, they don't have to ask any other team. So they have ownership. They don't need to get any approval for anyone. They own the project. They own the product. And with this, of course, the teams is focused on deliver features. It's very important because if you want to start having meetings, discussion with other departments, approvals and requirements and all that stuff, it's hard. Of course, we have some alignments with other teams. We have integrations and all that stuff. But the main idea is to have the team with all the capabilities and freedom to manage the product. Of course, very important, no handover. So from the idea until the production deployments, the team does not need to hand over anything to anyone. On the right side, one very important thing, as I already mentioned, in the teams we try to have people with all the capability or all the roles in teams, like the product owner, the software engineers, we have backends, frontends, architects, Scrum Master, UX, QA, and this means we have all the needed skills in one team to have an idea and again put it in production. But since we grow so much, we have now more than 50 teams and we are more than 240 employees. Of course, we need some alignment. Otherwise, we'll start creating silos in each team. And how we did so, on these roles, product owner, software engineer, we have some kind of cross-functional alignment. When, for example, all the POs sit together, they share experience, they share best practices, they learn from each other, and with this we have some kind of alignment instead of creating silos in these different areas. And this together is working pretty well. Of course, this not means that all the POs sit together in the same room, it depends. For example, architects, we have 7. We can have a weekly meeting, it's okay, but software engineers, we may have, I don't know, maybe 80 or something like that, we can't. So, of course, we need some local organization and then just share with the other locations. There is no, of course, straight rule. I've talked a lot about independency. This, of course, was a challenge for us when it comes to the technical part. So this was when we decided to create our platform. So in DevOps, we could have an infra guy in every team, but this is not possible. We have teams which are not so big. And that's why we decided to create our platform. The main idea was to give autonomy to the teams, try to automate almost everything. This is just the basic. And with that, the teams are focused on delivering software instead of having meetings, creating tickets, and all that stuff. Also, one very important aspect, reactive architecture, but decoupled. This is very important because this way each product has its own life cycle and can be deployed and managed independently, and of course we need a team to manage this platform. On the right, just a very, very high-level idea. We see our customer on the top, plenty of stuff on the cloud, which I don't know what it is and I don't want to know. So I'd say the first main point is Adobe Experience Manager, which is our CMS, content management system. When we receive the request from our clients, and then we start distributing the traffic to the backend applications on Pivotal, Cloud Foundry, our platform as a service. And here we see a first layer, or a first decouple of our architecture. So we have teams focused on AEM, we have teams focused on delivering backend apps on PCF, and then they can deploy all this stuff independently. They don't need to have a version which is a combination of several modules. Each team can do everything alone. And one very important aspect, the PCF provides us what we call the self-services. For example, if I want to create a new MySQL database or Progress or whatever it is, I don't need to ask anyone. I can go to PCF with a wizard and I just create it. I bind to my hub and it's done. So I can do this in a couple of minutes. So this is one of the stuff that our software engineers has to do. And of course, then we have our Bitbucket where our code is. And with these two entry points in our platform, we are able to build features and also bind the services and deliver the features to our customers. So there is no handover. There is no one else that we need to contact to basically implement a new feature. This is just an example of the pipelines we have in Jenkins. So any team, when they set up, for example, a new backend application, they get this pipeline for free. They can change it. So this is just an example: compilation, testing, code analysis, and trigger the deployments. So this is basically our blueprint, but the teams can change it. And on the right side, we have an example how I can create one MySQL database, and the hub, no hub is binded, but if I log into PCF, I would see a list of the hubs. I bind the database, and then it's done. So it's very simple. Since we are talking about DevOps, one very important aspect is to see if the things are going well. And how? We did it with KPIs. So we have a big initiative this year where we are trying to push even more the KPIs. We already have what is described here, but we want even more. So basically, we have one Grafana dashboard where we integrate a lot of data from different systems. Our issue tracking, which is Jira, CICD, Jenkins, continuous inspection, which is SonarQube, and our monitoring tools. And then with all this data in the same platform, we are able to start creating our KPIs. Here are just a few examples. The lead time, for example, we can measure and see how many time it takes from the beginning of the idea until it's ready for our customers in live. The code coverage, of course, is important, automation in this DevOps culture. The technical depth, so I would say it's better to keep it in a healthy status. The deployment frequency, so we strongly believe that we have to deploy, and deploy to reduce the risk. Average release duration, and we have many more. We also have, I didn't put it here because there is some sensitive information, but we also have KPIs like the leads, the number of leads we have, the income. So we are really measure not only these technical aspects, which are important, but also the business KPIs, which will tell us our top management if we are going well or not. Now I try to put everything together in one slide, just pretty simple. Our DevOps journey. So a product owner starts with the stories, comes up with an idea. He starts writing some stuff in our issue tracking. Then a software engineer pick up this story, start implementing, commit the code to our Git repository. And then we have our CI/CD platform, which for every commit, we'll, of course, build all the code and all that stuff. We'll deploy to a test environment. This is just a simplified, of course, version of our CI/CD. Then we have the testing phase. We still have some QAs. There are some teams which are fully automated in testing, and we don't have QAs. There are others where we still have, so it depends a lot on the product itself. But we are trying to go in a direction where everything is automated, and most of the times it is. Then we have the release process. We already have, for example, some teams where this release is just an increment of the version, so there is no need to create a specific release. It's just an automated step where we are basically burning numbers on every time we deploy something to an environment, because the idea is to try to go faster to the production environments. Then we have the PO, which gives an approval, and then it's in production. And if you take a look at this picture, we have the product owner, the software engineer, and the QA. And these three guys are able to have an idea and to put it in production. They don't need to ask any infra team or support team or any other team. They can just do it everything alone. So this is my last slide, lessons learned, very important. First point, automation is never finished. When we talk about automation, normally it can say you need to have some pipelines to build your code. This is just a start. Then we want to automate all the deployments, okay, but this is not enough. Then we need to automate the creation of databases, for example. And for example, at the moment, we are trying to optimize the way we manage our system access. If you imagine that we have 50 teams, and with people getting in our company every day, we can just go to every platform and grant permissions to these new joiners. So at the moment, we are trying to automate this, and this means the automation is never finished. So it's not critical, but it never ends. So after this automate this step, I'm quite sure we'll take a look in all our developments life cycle and say, okay, there is this process here that is still creating some turbulence in our teams, and we need to automate it also. Also very important, decoupling of components and teams for parallel development. This is also obvious, but if you want teams to manage a product and to be able to deploy it when they want, we cannot depend on other teams. If we have one product which is a combination of several modules, we have an alignment of all these teams, this is not going to work. So this is crucial. We still have some areas where we are improving, and we really see the difference between one team that is fully autonomous and can just deploy the stuff, and other teams where we need some alignment, and of course it's very hard. The platform as a service, PCF, which we use, is very good to ramp up new teams. So we just create one space in PCF, and then they are able to do the stuff on their own, but adds a dependency to a team to manage. So this DevOps team, which manage our PCF and our platform, is critical. So if their backlog is not in good health, then all the teams will start struggling. So this is why it's very important to always take a look in this backlog and see why there is so stuff there. So are they missing capacity? Just hire someone. Are they doing a lot of boilerplate and all that stuff? Just automate it. So this is something critical, because otherwise this will slow down the entire development process, especially when it comes to special needs to, for example, we want to migrate PCF to a new version or something like that. This is really important to have this team working and with the backlog not so high. Change your feedback and exchange model when needed. So when we started in 2017, we were just a few. So we were in Stuttgart, then we opened other offices, and we grow a lot, and this is extremely important to change this feedback and exchange model. And why? Because in the beginning we could sit together with all the developers in the same room. We're just a few, but at the moment it's impossible. We are more than maybe 80 developers. I don't even know, because we are growing every day or every week. But this means it depends a lot, and I already mentioned this a few slides ago. There are some roles, for example, architects, we are just a few, we can sit together. In other roles, maybe you have to organize locally, exchange, and then maybe find one representative to exchange with other locations. So if it's not working, your exchange, your feedback model, just change it, because this means your company are growing. And of course, what is valid today is not going to be valid in 1 year. Also, another very important topic, establish a collaboration model for some shared services. When it comes to this DevOps, there are different mixed feelings. There are some companies or even some guys that are working on this DevOps culture that say, okay, the teams has to be fully autonomy. They have to build everything from scratch. We don't did it. We don't did it, and I think it's a mistake. Because if we imagine, for example, the deployment on the PCF we have is something that is the same for every team, why should any team rebuild or reinvent the wheel? So this is why it's very important to have these shared services. But on the other end, if a team wants to improve this library, that team should be able to contribute, because this way other teams will benefit from these improvements. And this is why it is very important to define this collaboration model. In the beginning, when we start this DevOps adoption was very easy, because it was just a few, but at the moment it's no longer easy. So just define this collaboration model, because it's really important. And the last thing, also very important, continuous delivery sounds good, but sounds great, but it won't work here. This is all about culture. So I talk here about legacy. Yeah, we have legacy software, we have old technology, we have all that stuff, but it's still possible to do. So if we have this mindset, sounds great, but it won't work here, you will never get there. So we have to challenge yourself. If your architecture is not working, change it. If the teams are not working, so change the teams, do whatever. But this is all about culture, and you really have to believe that it's possible to do it. And this was pretty much what I have. So I tried to cover both functional, but also organizational, but also technical aspects. And I'm now open for questions. And even after Christina, you can come to me and ask questions if you want.
are the kind of projects you work on?
Yeah, very important. I forgot to mention that. So basically, we do everything that is not inside the car. That's not inside the car. So, for example, the Mercedes-Benz website is one example. So, currently we have OnWeb, which is one of our main projects, where we are basically rebuilding the Mercedes-Benz website, and is currently on more than 100 countries. This is one example. This is one area, OnWeb. We also have another area which is the e-commerce, when we are trying to sell cars online, let's be honest, or at least start getting into this world, and also have the digital services, where it's basically an area where we have hubs, not the hubs that are inside the car itself to exchange with the car, but it's hubs to, for example, if you are in a fuel station or you are on the road, you can, for example, find the closest fuel station with the best price, for example. So we don't build, for example, the software you see on the cars, it's not on us. So we are a company which we are working more on the marketing side, let's say this way.
Which kind of tests do you have in order to have continuous release?
Which kind of?
Tests.
Yeah. Yes, so basically it's not the same for all products, but mainly we have the unit testing, where we try to have the most we can. Then we have integration testing, where we basically, for each module, or for example, each microservice, we try to test everything at the same time. We also have, and we are introducing this now, one thing which is mutation testing. Mutation testing, for the ones who don't know, is basically a framework that goes into our code. It will comment some lines of code, it will change some assignments to ensure that our testings are covering that line. So this means that we may have, for example, 100% test coverage, but if we don't have the right asserts, it's not working, and the mutation testing give us a different perspective. So if our unit tests are properly implemented or not. And we also have the end-to-end testing, where basically we deploy our hub to one of the environments, and then we use, for example, the Chromium and the Selenium to test our applications in an automatic way.
Do you think there is a rule of thumb about the test coverage?
No, I think we have its common sense here. So I think we don't have it. For example, in our pipelines, we don't have some kind of a threshold. So this, because it depends a lot in the project itself. So we don't have a rule for that. So it's up to the team to decide it. But of course, it's important to have a good test coverage. This is for sure. And I think more than that, we have to ensure during our life cycle, during our sprints, it's important to keep this line in a good health, because otherwise this means maybe the team is with a lot of pressure, and then they start forgetting a little bit the quality. That's not good. But we don't have a specific threshold or a target threshold, so it depends. There are projects with 19%, there are others with 30%, especially the ones that we insource in Mercedes-Benz IO, so it depends a lot.
Have you guys tried any other cluster manager like Kubernetes, Apache Mesos instead of PCF? Or why did you choose the PCF?
Well, first, PCF is the pivotal. For the ones you don't know, this is the company which is behind Spring. And since Spring is our main framework, this is one of the reasons. But of course, we could try different ones. This is something we are thinking every day, if it's the right platform or not. One of the things we really like with the PCF is, if you take a look, for example, at all our backend applications, I can move one backend from one team to another, and PCF kind of forces us to work in a standard way in Spring, and it is pretty good. But of course, sometimes when it comes to freedom, we have to compromise, but there is no specific reason.
You talked about logging the metrics of each service you have. Do you have any standardization for each service that is created by each team? How does the team know what to log into a Grafana?
Yeah, very good question. So when we set up each project on Grafana, there is a default dashboard that we assign to all the teams. So they have kind of, for example, the lead time that I mentioned, the average release duration, the technical depth. So this is the standard dashboard that every team gets when they they join our platform, but then the team it's up to add more KPIs. But yeah, we have a kind of standard dashboard that all teams have in our Grafana dashboard.
Do you deploy for containers or program for containers?
PCF itself, how it works, the PCF, it's, for example, the backend part, but it's the same in the front end. So basically, we have a Spring Boot hub, and the PCF itself will create one container and then run the applications in a container. But we also have other areas, for example, the e-commerce area, where we are now making our apps cloud ready, and there we are using Docker, for example.
How do you manage the adherence to security compliance?
Okay, very good thing. So this platform has one owner, and this owner is someone that is aware of this security stuff, because as you see in this slide, so everything that is exposed to the internet is on our platform, and the teams, they can, for example, set up a new microservice, but when we are opening doors to the internet, this is not something the team can do. So they can open, but this product owner of this platform, he's aware, and we have very, very big or a lot of constraints when it comes to compliance. DAML has very strict rules, and basically the team that is managing this platform is responsible to ensure it. Of course, together with the teams, but this is something that is one of the responsibilities of this team.
Do you have how it is a support model, or if it is any kind of support model if you have like a customer that is complaining, how it works?
Sorry.
Support model. If you have any kind of support model, if you have a customer that is complaining exactly is not working as expected.
We have one company that takes care of the first line support, and then it depends if it's a team that is fully in-sourced in Mercedes-Benz IO or not. But basically, we have all the same levels that we have. So we have the first level, the second level, and then the third level is the teams. Sorry? Yeah, the last level is development team, yes. But of course, if it's a restart that is needed, there are some teams that can do it, and they don't have to call the developer for that.
One last question.
So you have self-service. How do you manage what gets created in development gets progressed correctly to test and plot? For example, to the new database, how do you make sure that it gets to the dev and test and plot?
There are several ways to do it. One of them is PCF itself. PCF is integrated with Spring. And for example, we have the Spring Act2Actor, which is basically one endpoint which every microservice exposes. And on that endpoint, it tells us if the application is able to communicate with the database. We can define some standard checks to, for example, communicate with other applications. This is one level. And for example, if it's not working, the PCF itself will try to restart the application. This is just the first thing. The second thing is, of course, smoke tests. So this first part just ensures that the application is ready to communicate with all the components. And the second part is with some smoke tests. We try to, of course, automate. And the smoke tests, for example, if you see one user journey that someone's in AEM that is doing a request, which calls, for example, 3 backend services, we can try to create one scenario which cover all these interactions, and then it's working. But it's not a standard way. We try to automate it. For example, one project I've worked last year, after each deployment of in each environment, we have some acceptance tests with Selenium, which basically open a browser and test the application. And with that, I'm sure that everything is working.
You have only one database for all these lines?
No, sorry. No, this is just a simplified version. We have test, int, and prod environment and pre-prod. So we don't have a single database. We don't have a database per product. It's one per environment.
Okay, so how do you make sure that what was typically there?
I don't know if it's how technical is your question, but for example, if it's the database itself, there is one framework which is Flyaway, where, for example, I create the SQL script, and then it has kind of a table on the database, and each version of the application has one version, and then he upgrades the database automatically, and the teams does not have to connect to the database. They can do it, but it's not. And this is also a way to force us to update the database in the right way, instead of just connecting, update some columns, and pray that the application works.
And thank you, André.
Okay, thank you all.